this masterclass because we believe the exchange of knowledge always was one of bases of Visto.bio, and that is what helped us elaborate rapid responses to the pandemic and receive the global recognition from Singularity University. Together, we are working to leave the world a little bit better than when we arrived. Thank you, Alanna, for this unique opportunity to have you in our homes. Your book was the most engaging that I ever read in my life. I have it in Audible and in Kindle. And while I was reading, it put me in a flow that I can't stop reading. Thank you for that very exquisite experience.
You're very welcome, and I'm very flattered. Thank you. I'm really glad you enjoyed it. It was an absolute pleasure to write. It was an experience for me as well, because it was not my subject area. So learning about all those things was a journey for me too. And I wanted to convey that journey through my book, so that the readers felt like they were on that same journey as I went through. So I'm going to give you a really broad overview. I haven't got so long today, so just a very broad overview of the role of microbes in human health. So my name is Dr. Alanna Collen. I have a PhD. I'm not a medical doctor, and I wrote the book 10% Human back in 2015. And it's not actually how I started out. My initial career was as a zoologist. I did a PhD in the evolutionary biology of bats. So that meant that I was lucky enough to spend a huge amount of time in rainforests and loads of other habitats, but I mostly worked in Southeast Asia, catching bats in tropical forests and recording their echolocation calls. So it was on one of these trips way back in 2005 that I had finished collecting bats for the night, and I was walking back with all these bats hanging around my neck, and I realized that my ankles were extremely itchy. So once I'd finished looking after the bats and sorting them all out, I went back to my hammock and zipped myself in and started the process of removing probably about 50 to 100 ticks from my ankles, which had embedded themselves there. So I clearly walked through a tick nest. And you kind of, when you're a tropical biologist, you get quite used to dealing with parasites. But I have to say it was a bit of a shock. And I was aware that ticks can transmit disease. So I was quite keen to get them out. And then once I'd got them out, I was quite alert for anything that might happen next that might mean that I needed some medical help. And sure enough, a few weeks later, I started to, I basically woke up feeling horrendous, like I'd been hit by a truck, and my muscles ached, my joints ached. I was so stiff and I couldn't stay awake. And I went through a few weeks of this with the doctor doing various tests on me. This was back in the UK. And they couldn't figure out what was wrong. And then it went away. So I thought nothing more of it. And then a few months later, the same thing happened again. And then again, it went away. And it kept doing that for several, years, before one doctor said, perhaps you have contracted an illness from the ticks, and tested me for Lyme disease and decided that I had some Southeast Asian version of a tick-borne disease. And so that then meant that I had a year and a half of antibiotics, multiple kinds of antibiotics. By then I also had a bone infection. So I was given intravenous antibiotics and antibiotics embedded within the bone of my foot. And the nice thing about this was that I started to feel a bit better. And I was pretty pleased. I was getting there, but I also noticed that every time I tried to come off the antibiotics, I would get horrendous acne. And for the first time in my life, at the age of about 28, I developed hay fever. And I just kept getting infections, ear infections, all sorts. So I started to think something is going on here. Did a little bit of reading on the internet and decided I'd perhaps damaged my good microbes with all of these antibiotics. And that was all I knew at that point, that we had good bacteria in our guts and antibiotics could harm them. So I went to my doctor and said, I think I've damaged my good bacteria, and that's why I'm now have all these new problems. And he said, don't be ridiculous. That's not a thing. Those microbes are just there and living off the food in your gut. They don't do anything for you. You can't damage them, and it wouldn't make you ill. And I was very frustrated and surprised by this. But I went home and I started doing some more research, but in a bit more of a scientific way. And I discovered that, in fact, I'd stumbled upon an area of science I'd been completely unaware of. And there were very many articles being printed in top journals talking about the role of the microbiome, the gut microbes in health, and how important they were. And I was hooked. I felt like this was the answer to all of these things that I was struggling with. And I could not stop reading about it. And that is what led to me writing 10% Human. So you might already be aware that we have around 100 trillion microbes living in and on us. The majority of them are in our guts, but they are literally everywhere else. They're all over our skin, into all of the organs that are exposed to the outside world. And they form a sort of second layer over us, whether that's on the outside or in our inner tube. And these 100 trillion microbes actually probably outnumber human cells. They have a crucial role in running our bodies. The majority of them are based in the colon, which is the large intestine. And this is also where the majority of our immune system is based. The microbes and the immune system communicate constantly, and they do that from the very first moment that microbes enter the gut. And this communication is fundamental to our health and our mental health. And in fact, we now know that there are huge numbers of conditions that were just not common 50 to 100 years ago, and now are extremely common. And in fact, in my own friends group, I barely know someone who doesn't have one of these conditions. They've become very common, and we now know that all of them are connected to your microbes. So allergies is one, which ranges from just a minor irritation of hay fever every year to fatal allergies, food allergies, and so on. Autoimmune diseases, from things like type 1 diabetes to lupus to rheumatoid arthritis, have become extremely common. Mental health is also affected, including depression and anxiety, and more neurological, so neuropsychiatric disorders such as OCD and autism in particular are affected by our microbes. And obesity. So obesity is important. It's not just the symptom of having excess weight or excess fat on the body, but also many metabolic changes that are going on, such as type 2 diabetes and high cholesterol, high blood pressure, which all form the syndrome, metabolic syndrome. And we now know that microbes are playing a crucial role in determining how much weight we carry on our bodies. And then there are a number of other things, including cancer, lactose intolerance, Alzheimer's disease, Parkinson's, all sorts of things. We are now understanding that microbes have a role to play as well. So today I'm just going to give you a little bit of insight into obesity because I think it's particularly interesting and relevant at the moment. It's also hopefully will be the subject of my next book. This is a fantastic experiment. It's so elegantly designed and so interesting. Scientists took a handful of identical twins in which each pair, one was lean and the other was obese. And they took the microbes from the guts of these women and transferred them into identical germ-free mice. So these are mice that have no microbes whatsoever living in their guts. They are raised in a bubble, they're completely sterile. And so when you add microbes from something else, you can see exactly what the microbes do. And so taking microbes from the lean and placing them into a mouse, and taking them from the obese lady and placing them into the mouse, and this is what happens to those mice. So the only difference between these mice is the microbes that they have. They are genetically identical mice. They've come from genetically identical women, the microbes. And the mice that gain weight do not eat any more food than they used to, and they do not exercise any less than they used to. The mice eat the same amounts of food. In fact, the obese ones eat ever so slightly less than the slim ones. So the only difference that's causing these mice to gain weight is their microbes. So you can see that our microbes are crucial to our health. They play a really significant role in the running of our bodies. They interact with our immune systems, with our metabolism, with the skin, with our brains, and with our other organs. And looking after the microbiome is extremely important. So I'm now going to share with you just a few ways that we can do this. Some of them are really, really simple. The first one, probably the most useful thing that I can tell you today, is to eat more plants. And that's not to say that you need to go vegan or you need to be vegetarian. You can eat animal products, you can eat meat. That's part of our evolutionary history. But I suspect that most people eat too many animal products and not enough plant products. So, and also those who are eating plants, I suspect that most people are focused on the bottom layer of this pyramid, which is vegetables and fruit. Probably too much fruit and too little vegetables. But if you look at the other layers, they also have a lot to add in terms of their contribution to your microbes and your health. So grains and legumes, nuts, seeds, leaves, all have different fibers in them. And it's the fiber in these plants that is so crucial for your health. So much of that fiber will pass straight through your small intestine where you digest food for yourself and into your large intestine where the majority of your microbes are waiting. And they will digest that food for you. And that has a number of benefits. The first one is that it creates a healthy mucus layer over the lining of your gut and a healthy layer of microbes over that mucus layer and within that mucus layer. And those protect you from the harmful products in your gut getting through into your bloodstream where they can irritate your immune system and create inflammation. At the root of all these disorders is inflammation. The next important thing that they do is by consuming the fiber you eat, they then produce compounds and chemicals that interact with your body. So that might be directly with the immune system cells that are sitting in the lining of the gut, or it might be indirectly via the vagus nerve up to your brain to tell your brain what's going on in your gut and what's going on in your body. And both of these mechanisms are extremely important when it comes to your health. The next thing is natural birth and breastfeeding. So the way that we get our microbes in the first place is from our mums when we're born. So if a baby is born naturally, they emerge coated in vaginal and fecal microbes. And that might sound absolutely disgusting, but it is so important. Their mouth and their nose are filled with vaginal and fecal microbes. They travel down to the baby's gut, where they have, several functions. One is that they protect the gut from infections caused by harmful pathogens, microbes. And another is that they start a colony that enables the immune system to be trained as to what is important and what is not. So the immune system shouldn't react to food, it shouldn't react to pollen, but it should react to cancer cells, and it should react to harmful microbes. And the microbes that you get from your mum help you to distinguish between those two things. So if you're not born naturally, if you're born by a cesarean section, you are not exposed to your mum's vaginal and fecal microbes. Instead, you're exposed to your mum's skin microbes, the skin microbes of the doctors and nurses, and unfortunately, quite a lot of hospital microbes as well, some of which are not so nice. And we know that babies born by cesarean are much more likely to contract infections in their early life. We also know that they're more likely to become allergic, to have autoimmune diseases, and even to become obese. Now, clearly, C-sections are crucial, and I would never suggest that people shouldn't be able to have a C-section because they save babies' lives and they save mothers' lives and they prevent a lot of harm. But we know that we overuse them. So the WHO recommends a rate of about 10 to 15% of births should be by C-section, and that's the optimum rate to prevent harm to mothers and babies. Most countries are way above this rate. You may well be aware that Brazil has one of the highest rates of C-sections in the world. Around 90 to 95% of babies born in Brazil are born by C-section, especially in cities. And sadly, that is not the ideal way for encouraging a healthy microbiome for a newborn baby. So the second part of this is breastfeeding. Again, I would never wish to say that formula feeding was not something that people should do, because it helps to save lives and keep everybody healthy, and not everybody is able to breastfeed or breastfeed successfully. But again, breastfeeding is encourages exactly the right microbes. So it provides sugars that they don't feed the baby, they go straight through the baby's, the small intestine, and they go to the large intestine where they feed the microbes. And that enables the baby to resist harmful microbes that might give it an infection. And the breast milk encourages a population of microbes that really benefits the baby's immune system and helps to train it as to what matters and what doesn't. So the next thing, we've got eat more plants and we've got natural birth and breastfeeding. And the next thing that's really important is to avoid unnecessary antibiotics. Antibiotics, once again, they're brilliant. They save lives. They are really, really important. And when you need them, you need them. But we also know that we massively overuse them. Approximately half of antibiotic prescriptions are unnecessary. Antibiotics are given out when people have viral illnesses where they will not help, and they may well harm because they interfere with the natural microbiome that can help a person to get better of their own accord. So it's crucial that we reduce our use of antibiotics by having conversations with our doctors about whether antibiotics are absolutely necessary, whether you might get better on your own. What are the risks if I choose not to take antibiotics? Could my infection develop into something more serious? Could I delay taking antibiotics to see whether my body starts to take over and heal this infection on its own? These are the questions that you should be asking alongside your doctor to try to make a decision about whether antibiotics are the best thing for you to do for yourself or for your child. So the other element of antibiotics, I want to go back to the obesity section of the talk here. We knew from when they were first mass produced in the 40s that they could make people gain weight. So almost immediately when they started to be given to animals, farmers noticed that they made animals gain weight, and they loved it because it meant that those animals were quicker to market and they could produce more of them. We also discovered that giving premature babies antibiotics would help them gain weight, which is very useful when things are so precarious, when a baby is so small. And there was a study in soldiers in the 1950s in the British Army, where a group of soldiers were given antibiotics to test whether they might resist infections while on duty. And they did a placebo arm where another group of soldiers were given a pill that was just a sugar pill, a placebo, not an antibiotic. And being the army, they were very officious, and they recorded the heights and weights of all of the soldiers at the beginning of the experiment and at the end of the experiment. And they found that the antibiotics made absolutely no difference to whether you were likely to develop infections or not. But all of the soldiers who'd been given the antibiotics had gained weight, whereas those who hadn't been given them had stayed the same weight. And we now know that when women have antibiotics in pregnancy, their baby is much more likely to grow up, or to be born heavier and to also grow up heavier. So we've known for a long time that antibiotics can induce weight gain. And in fact, experiments show the same thing. If you take two mice and you give two groups of mice, you give one group low dose penicillin, you can see that it changes the bacteria in those baby mice. And that results in the adult mice being overweight relative to those who didn't receive the antibiotics. Then once again, just as with the twins, the human twins, If you transfer those microbes from those 2 mice into germ-free mice, then those that receive the microbes that have been affected by antibiotics will gain weight, whereas the others will remain lean. So we can see once again that this is the microbes that are making this change. It's not the antibiotics themselves that are doing that, it's the microbes that result from taking those antibiotics. We also know that this acts in an additive way with the diet. So the bottom 2 lines, you can see that as mice age and gain weight, if they are given a normal diet, they remain lean. If they are given a high-fat diet but no penicillin, they gain a little bit of weight. But if they're given both penicillin and a high-fat diet, they gain a huge amount of weight and become very overweight. So there's a joint action between the antibiotics and the diet that makes the diet significantly more weight promoting. So the final thing, so we've got eat more plants, we've got natural birth and breastfeeding, and we've got avoid antibiotics. And the final thing I wanted to talk about was reducing chemical use. And now this is actually quite similar as a concept to avoiding antibiotics, because although antibiotics are overtly killing bacteria, chemicals may be killing or altering the communities of bacteria that live on and in our bodies as well. And in a typical day, you've probably used around 100 chemicals or become exposed to 100 chemicals just in the first couple of hours of your day, from the fire retardants that will be in your mattress, in your sofa, in your carpet, to the chemicals that you use when you wash yourself in the shower and put your makeup on, to the chemicals in your food that are not natural foodstuffs, and then of course the chemicals in water and in the air, pollution as you go outside. And many of these obviously are things that are not ideal, that we don't want, and others are things that we are actively choosing to use, such as cosmetics. They are everywhere, and the action of them is not only about killing bacteria, but about altering the bacteria that are present in our guts and on our skin, away from what's natural, what our body expects, what evolution has created, and towards something that's different, something that can provoke your immune system and change the natural balance. So the skin microbiome, I'm sure several of you know this very well. You might think it's just one similar thing, it's one organ, and so the microbes that live on your skin are going to be the same, but actually if you think about it, like planet Earth, it has a huge number of different habitats, and they can be very changeable depending on what's happening. So for example, the skin of your forearms is somewhat like an arid grassland, cool arid grassland type of habitat, with dry skin that's relatively cool compared to the rest of your body, with some hairs. And that's going to encourage a different microbiome, for example, from the skin on your foot, which is, I've represented it here as a limestone plateau, which is cool, can be hot, can be dry, can be wet, very rugged, lots of crevices, places for microbes to hide, thick skin in some places, thin skin in others. And in fact, the number of habitats and on a human foot is probably more than the planet Earth. And each of these places will have a different collection of microbes, a different community living there. And one that some of you will be very familiar with is the armpits, which can be compared probably to a tropical rainforest. It's warm, it's moist, it's got all sorts of chemicals being secreted out of the glands there. And there's hair in many cases, and that makes for, again, another habitat for bacteria to be living in. And all of these places can suffer from skin conditions that are at least in part thought to be related to changes to the microbiome that we might be inducing, that might be coming from our inside and affecting our skin, or might be affecting, starting with the skin and moving inside. And of course, genetics plays a role as well. And we do have still a huge amount to learn about the skin microbiome and the role that microbes play in each of the conditions that we've already identified in skin. But what we do know is that adding many cosmetics will change the microbiome, and also the things that we eat can change the microbiome of the skin, and that's likely to be very important. So in a similar way, I wanted to talk about probiotic products, because this is a new area of the market that's becoming quite popular. There's an increasing demand for people to move away from chemical-based things, based products, and towards more natural products. And probiotics fulfill quite a few of people's criteria on this front, because they are natural and they are more in sync with our bodies. So I wanted to show you this this figure because it gives you an idea of how these differ when it comes to cleaning. Now, cleaning is a bit of a strange one in the first place, because we are all hooked on antibacterial cleaners. And in fact, there's no benefit of antibacterial cleaners over normal warm water and soap, which doesn't have antibacterial compounds in it. When you clean your kitchen surfaces, what you're doing, or what you're trying to do, is remove the foods and dirt that sits on top of those surfaces that bacteria can live on. And if you use an antibacterial, that doesn't actually help. In fact, it harms you, because they are known to be to cause respiratory diseases. So a chemical cleaner, you wipe it over. If you use an antibacterial cleaner, it will remove, let's say, 99.9% of those bacteria, because that's what they love to claim on the bottles. And that sounds fantastic, right? But bacteria grow really, really quickly. They multiply really quickly. So not all that long after you finish cleaning, your kitchen surface will be repopulated with those same bacteria. And in fact, it's worse than that, because all the sensitive ones will have been killed off completely. And the more hardy ones that are more likely to cause disease will have survived the chemical cleaning and will proliferate on your counter. So they'll be the ones that are growing there. So it's a vicious cycle. Probiotic cleaners, on the other hand, use a different strategy. So that, again, you're wiping away the dirt, which is always going to reduce the number of microbes present. But with a probiotic cleaner, you are then adding beneficial microbes, which are harmless, because they are usually the same microbes that would be found in your gut anyway. And those microbes can then grow and outcompete the pathogens, the harmful bacteria that are on your counter. And that effect continues for several days. So over the course of hours and days, your counters will get cleaner. They'll become, and this is a new way of using the word clean. That doesn't mean nothing. That means that there's nothing harmful. So they will become coated in beneficial microbes, which is better all round. So I wanted to touch on COVID-19 and the microbiome as well. This is definitely not my specialist area. But there is a relationship between the severity of a COVID-19 infection and the microbiome. There have been studies that have shown that people with altered and disrupted gut microbiomes are more susceptible to the worst effects of COVID-19. And we also know that the microbes that we have in our guts can impact on the accessibility of coronavirus into the cells of the gut, because the gut actually has the same receptors that the lungs do, that the COVID virus uses to get access to cells. And we also know that the gut microbiome is actually really important when it comes to beating a respiratory infection, and not specifically COVID-19, but respiratory infections do benefit from a healthy gut. You're less likely to suffer the worst effects of respiratory infections if your gut is more healthy, and that again is because of the connection with the immune system. We also know that supplementation with probiotics can help with respiratory infections. And in fact, there has been a study that's been done that shows that supplementing with probiotics in the case of COVID-19 can create an 8-fold reduction in the number of people needing to go onto a ventilator. So it's a growing area of research, and there's lots more to consider there, but certainly it is important. So where next for this area of science and the technologies that it can suggest? Well, what I would like to see very much is a phasing out of the use of products that disrupt the natural and healthy microbiome, and a phasing in of products that allow it to either remain in its natural state or replace a damaged microbiome with a healthy one, or rebuild a microbiome to its healthy state. And that's where I think Visto.bio is onto a good thing, because that is one of the aims of your products, I believe. And I think you should be very proud of the work you're doing on the forefront of science here, reducing our use of chemicals and moving towards a more natural way of treating our bodies. And I wish you the very best of luck in what you're trying to achieve. It's very worthwhile. So it's been a pleasure talking to you, and I'm looking forward to taking your questions. Thank you very much.
Thank you, Alanna. It was a very mind-blowing talk. How did your acne look now? He sent here on the chat.
Shall I come
How
really
did you
close to the camera? I don't generally have acne anymore. Thankfully, I think it's probably just partly the passing of the years. I'm moving into the wrinkles phase now, unfortunately. But I think it's partly that, partly diet. I would never take antibiotics for acne again, because I think that ultimately that was the cause. I think that disrupted my natural microbiome, and it took a long time to get a balance back that allowed me to have clear skin again. And I guess I used some cosmetics to help remove dead skin from the surface of my face as well. I don't want to pretend that this is all through eating broccoli or anything. But yeah, I think time away from antibiotics and that kind of disturbance has been crucial.
And you solve it by taking probiotics also, or not?
I do take probiotics. Yes, there's not brilliant evidence for taking probiotics for acne or for there's some quite nice lists that you can find. The US and Canada have a website that allows you to look for which probiotics have the best evidence for any given condition, and I'm talking about whole body conditions, not necessarily skin conditions. And I think if you're in generally good health, then they possibly don't do a huge amount, but then again they might. So if you did want to take probiotics without any particular condition, then my thought would be to take one that has a lot of species, a lot of strains, and a high number, in the hope that it's basically bet hedging, that the hope that some of those ones will benefit you. I also don't think you necessarily need to be able to feel a benefit for there to be a benefit taking place in your body.
And how about, I know that you're not be 100% sure about your answer, but how about cleaning our tongue? Maybe this could disrupt or hurt our microbiome?
It depends what you're using, I would say, because I think physically cleaning anything, you will leave so many bacteria behind that they will recolonize really quickly. So you could clean your hands with alcohol gel, say, and if you then just, rub your hands on your arms, then you're covering yourself back in bacteria that will protect you again. And I know a lot of people are getting eczema from all the hand washing and alcohol use that's going on at the moment, because they're disrupting the barrier on top of their skin, and potentially also because they're altering their microbiome. But I think with cleaning teeth and cleaning your tongue, it's probably more significant what chemicals you're using than how you're cleaning or what parts of your mouth you're cleaning. Until a few years ago, triclosan was a standard ingredient in toothpaste. I wrote about it in my birthday pact. It's an antibacterial product, and you can see the logic. You're trying to get rid of bacteria in your mouth to prevent any kind of gum disease or plaque building up and so on. But unfortunately, it's quite a harmful chemical. It has been associated with changes in mouth cells, and oral cancer, and they have actually changed it now. I only recently learned that it's now not used in toothpaste anymore, and they are using different, less harmful compounds that still
Yeah,
manage to remove
but
bacteria. But again, the most important thing is that you're removing food, you're removing the substrates that bacteria can live on, and not so much about killing off bacteria that
okay.
are already there.
Yeah, so this is triggers me the next question. That's this super clean environment for children in the COVID scenario. You see what consequences you see that can have for these future generations?
Yeah, it's not ideal, that's for sure. I think it's difficult because it's very important at the moment, and there's a very fine line between not taking hygiene too far for the sake of our microbiomes and not catching and spreading COVID and other
Hmm.
illnesses. I think that probably we're using a lot of products that are not ideal. Um, I know I have a 4-year-old daughter myself, and she goes to school, and I know that so many of the children at school have eczema on their hands at the moment because they're being made to wash them all the time, and they're using incredibly harsh antibacterial
Wow,
soaps.
so sad.
And I think that if we had a better set of products that were tested, probiotic soaps that don't contain antibacterials but do allow you to remove harmful microbes through the use of emulsifiers that take off any food or any snot or secretions that might be on your hands, that might help. In terms of these children's health going forward, that's a tricky one. The original hygiene hypothesis was that children were not exposed to infections, and that then made them more susceptible to developing allergies and autoimmune diseases and so on. The hygiene hypothesis has been slightly updated in that we now understand that it's not necessarily exposure to infectious organisms, but more to microbes at all that causes the increase in allergies. So although children are having to wash their hands a lot and be hyper clean, that doesn't necessarily stop them from having exposure to microbes in the soil if they're allowed to play in the mud or do some gardening, or having exposure to microbes in the home if you're not necessarily, there's not huge reasons to keep your home any cleaner than you would have kept it before COVID, because it's all within one household anyway. And so I hope that some of that effect can be mitigated by children having exposure to normal microbes. And I also hope that they're not all going to get a complex about keeping extremely clean and thinking that that's very important. I've seen some, I think, I wish I had them to show you, but I've seen some quite funny photos of children going up to all sorts of things on the wall and putting their hands underneath because they're expecting hand sanitizer to come out of them. At the age of 3, they've already got this fixed in their head that if there's something on the wall, then it probably dispenses hand sanitizer. So I hope they'll manage to get over that as things return to normal.
Yeah, so the alcohol gel is like triclosan. Triclosan causes cancer, but they are doing the same thing, right? So I saw that FDA banned triclosan
Yeah,
2 years ago, but here in Brazil they are freely selling products with that.
oh
And
really?
now companies in US, they already are using safer ingredients, but you see that it still are harmful, right, for the microbiome.
It's likely the other point is that not only is it killing the microbiome, but any compound could change the composition of the microbiome, and that's not necessarily ideal. I would point
Okay.
out that alcohol is not known to be carcinogenic, and alcohol works on microbes at a very basic level. So it kills them at a very basic level in quite a different way from an antibiotic would. And so I don't think we need to be overly concerned about the use of alcohol in terms of alcohol gel in the same terms that we would about triclosan. And I think the important thing with that is to try to use a moisturizer that creates a barrier layer again, so that your skin can restore itself, at least as a temporary fix while we're going through COVID.
Great tip. Create a barrier. Yeah, I will have this in my mind every day right now. How about the microbiome exchange in people that live in the same house? It happens where it happens.
Oh, there's a huge exchange. People's microbes become much more similar, just from door handles, surfaces, chairs, everything that you touch, you exchange microbes. And obviously in your household, if you kiss your partner or you kiss your children or anything like that, you're exchanging more microbes. And actually it's fascinating because you can see microbial signatures of cities. You can actually tell what city someone lives in from their microbes, because they are touching the same public transport, the same benches and all sorts. It's absolutely crazy, but you do actually conform to your city as well as to your household.
So we are wondering here, like our dishing, our our food, washing our food in the kitchen, and the thing to wash it maybe have a lot of microbials that can transfer to your plates and your fork.
Yeah, that's certainly true. And the same
Okay.
the same goes with food, of course. And one of the main sources of microbes that are living in humans is soil, because we consume soil when we consume food, and that's probably part of the problem. Is our food is a lot cleaner than it ever has been before, or it's covered in pesticides rather than in soil. And another major source of microbes, if you look at their ancestry in the human, is the same kinds of microbes as you see in cows, because we've always had such a close relationship with cows, or at least people in Europe have, and consume their products. So there's a lot of crossover there as well.
Okay, so I have 3 more questions before the journalists. I would like to introduce more about our area, the deodorants. I saw something in your book, but I don't remember that relationships had been destroyed by deodorants.
Yeah, I mean, it's quite a scary thought that we know that people find people attractive based on their smell, whether they realize it or not, and that we probably give out certain pheromones that are detected in some kind of specialized part of our noses. And we know that men find women's smell more attractive when they're coming up to ovulation, which is the point that they'd be capable of conceiving, than they do at other times in their menstrual cycle. And so if a woman is on the pill, for example, then she might not be producing the same smells as she would be if she were not on the pill, and that could potentially change who is attracted to her. And I think there's just also deodorants, as you said, if you're wearing deodorants or antiperspirants, then you're masking somewhat your natural smell, or a natural smell that you could have if your microbes were as they might have been before you started using deodorants. And yeah, in theory, at least, that could have an impact on who's attracted to you and who you're attracted to, and could set up relationships that maybe wouldn't have otherwise been.
Perfect. And I would like to explain a little bit about our concept on the deodorants. Is that we see it as a barrier, our formulation, because we understand that the bacteria that cause the bad odor is the bacteria from the outside environment. So here, from the air, and they attach here in our clothes and our body. And we are saying to our clients that if we create this protection against outside bacteria, they will avoid the cross contamination. You enjoy this kind of concept?
Yeah, I mean, I think this is probably one for Chris rather than me, but my understanding was more that they don't alter the community that's already present, that should be present, as deodorants and antiperspirants do. And therefore, the microbes that are left behind on your skin and also, of course, on your clothes are ones that don't turn odorless sweat into smelly sweat that's unpleasant.
Perfect. And my last
can I quickly pick up on that? So what do you mean bacteria that are coming from the environment? It's really the bacteria that are on our skin. The thing is, we have about 100 or 200 or even more different kind of bacteria, and it's not so much the bacteria here in our air that will attach on us. It's really more the bacteria that are already on our clothes or already on our skin that will proliferate. You know, we feed those bacteria with our sweat, and as such, bacteria will grow and create some sort of odor. So I don't really understand what you mean with bacteria from the environment.
Yeah, because we saw that when people repeat their bath towel, they increase the bacterium in their armpits, and their bacterium are staphylococcus from the, when you do your things on the bathroom, and that bacteria goes into the air and attach to the towel. And then we saw that if we create protections in that towel, you create protection on your armpits, you avoid the attach of this new bacteria.
I see. But the thing with the towel is really correct. Bacteria do grow in cotton and polyester and textiles, and that is a big source of bacteria. Also, your laundry machine, there's a lot of bacteria in there that will go on your clothes and then can have an impact. So yeah, that's definitely correct.
Thank you. And my last question that I have here, that's you say that in the future, broad spectrum biomakers could detect virus and avoid people taking a lot of antibiotics before they know if it's a virus or it's a bacteria. So we are thinking that you think that could be useful, like if you have like something in your ear or your throat, then you apply a virus seed spray and test it very fast if it solves the problem, or the problem keeps going, then you know that it's bacteria problem.
That's quite a novel idea, not one that I've ever heard of before. I think one of the issues there would be that it might take time for a viricide to work, just as it takes time for an antibiotic to work. I'm trying to think that one through quickly.
No problem.
It is a very difficult problem, the amount of time it takes to tell what someone's suffering from when it's an infection. There are very few diagnostic tests that are worth the cost. And or have even been developed. So generally speaking, a family doctor could not tell you whether you have a bacterial illness or a viral illness. So you're absolutely right on that front. And there are lots of things about whether your phlegm is green or what the sound of your cough is, and none of that actually correlates with what you're suffering from, whether it's viral or bacterial. Yeah, that's an interesting idea. I know there are viral sprays that you can buy that you spray up your nose at the first sign of a cold, which supposedly trap viruses and prevent them from taking hold. And they have shown some clinical efficiency. So it's feasible. Yeah. It's feasible.
Yeah. Nice. And the obesity is also a virus, or I understand wrong?
No, well, obesity is highly multifactorial. There are all sorts of things that contribute to obesity. That I did write in my book about a viral cause of obesity, which is there are a couple actually. AD36, adenovirus 36, is a respiratory virus, basically a cold, and it was discovered to be creating an increased risk of obesity. More people who are obese have antibodies to AD36 than people who are lean. And I think it's plausible that there are other viruses that contribute to your risk of obesity as well. And it does that by telling the fat cells in your body to produce to grow larger and ask for more fat to fill themselves. I actually just read today that they're concerned that there's COVID-19 can induce diabetes, both kinds of diabetes or some new kind of diabetes, by damaging the pancreas and altering the way sugar metabolism works. So we do know that viruses can have impacts beyond the kind of standard infectious disease. We also know that they can cause cancer. Certain cancers are caused by viruses as well. But it's certainly not the only cause of obesity or even the major cause of obesity. But yeah, it can play its part.
Thank you. So one of the pieces of advice you shared with us was avoid unnecessary antibiotics. But numerous studies around the world have shown that even with no efficacy and sometimes no proven need to combat COVID-19, antibiotics are being widely used during the pandemic, right? So I would like to know, what effects do you think this can have on an individual, but also on a community level, you know?
So there is some use of antibiotics in COVID-19 that is justified, because sometimes people, when they have a bad case of the disease, will get concurrent bacterial infections of the lungs. There's some evidence as well, there's an antibiotic that is not only antibacterial, but also anti-inflammatory. And that anti-inflammatory action can benefit a patient who's overinflamed. I had not read that people were being given antibiotics outside of these reasons, but if they are, then I think overall that's unlikely to be a good thing. On an individual level, it can have two effects. One is that it can cause antibiotic resistance in that person. We often think of antibiotic resistance as a problem for society, but it is a problem for the individual, because if you use antibiotics when you have an infection, the next time you get that infection, those antibiotics will be less effective. The second problem is the problem of collateral damage. So you damage the microbes in your gut, which alters the way that your immune system works. You may also change the microbes in your respiratory tract, which could make you more vulnerable to the impact of COVID-19. The societal effects are actually exactly the same, but on a broad scale, both in terms of creating antibiotic resistance and leaving us with no drugs to treat infections, and in terms of collateral damage and the impact on people's health through allergies, autoimmunity, obesity, and mental health problems. So if people are being offered antibiotics with a mild case of COVID-19, I don't think there's, as far as I'm aware, there's no justification for that, and it's not to be advised. But as I said, I'm not a COVID expert and I'm not a medical doctor, so there may be reasons that I'm unaware of in individual cases or more broadly.
Meetings like this one are important because we can advance in our responses and anticipate the next questions. So in summary, the core is that we truly believe that we are just a few connections, as you can see, away from solving the great challenges of our era, like human connections, technology, and resources. I'm very pleased because we have like the two most important scientists. I don't know if it's for the world, but for us, it's our two most important scientists. You guys have a lot of research around that and knowledge, and you guys are helping us to disseminate and develop this new kind of solutions for our society. Thank you for the journalists that are here today. You guys are the vector to the shift of our society. You guys are the real influencers because you decode the message to the masses. I would like to thank Visto.bio team that is here and is 100% committed to develop and disseminate solutions that stimulate the body's natural protection, reduces wastes, increases life quality, and left a positive legacy for future generations.